Hello and welcome back to another ICEWORLD podcast. I'm your host, Nadia Frontier. I recorded this episode just before Christmas 2024 on Zoom with Floortje Van Den Heuvel while she was in Antarctica. Her name is shortened to Floor, which is much easier for English native speakers like me to say. She was joining us live from Rother Research Station, or as live can be, continuing with the theme of conducting science in Antarctica. Floor, what's the view outside of your window? Where are you right now?
So right now I'm sitting in my bedroom, so I'm not looking out of the window, but let me just check. I'm looking out on the ramp, which is basically our local skiing area, if you like. So, and onto the runway. So not a bad view.
And what has your day consisted of today?
So today, because we've stopped flying, we've been mostly packing up our stuff, writing out these bits of paper so that we can send it back to Cambridge. And as we also have some instruments that we run on the station, just checking up on those instruments, make sure that they're working properly. That's part of our daily routine, really.
And how long have you been at Rotherham this season?
It's been about 6 weeks this season.
Wow, that's a really short amount of time. And now you're just on your last couple of days. You've told me that you're flying out on Thursday. So I'm really appreciative that you've made time to be able to share your story on the ICEWORLD podcast.
Of course, I wouldn't want to miss it.
Let's start from the beginning about skills and experience that you have accumulated before becoming an Antarctic cloud physicist. So where did you study your degree?
Yeah, so funnily enough, I did my undergraduate in international relations in the Netherlands, which is also it's always a bit of a weird one that people don't see coming. The end of our undergraduate, you can do something called Erasmus, which is really popular in sort of Europe and on the continent. And Erasmus allowed me to go to France for a whole semester, and I could choose whichever subject I wanted. So I chose environmental sciences and discovered that was absolutely what I wanted to do.
Wow. And where did you do your master's?
Did my master's in Geneva in Switzerland.
Okay, so now we start to get like the snow-capped mountains, this kind of
absolutely.
Antarctic feel. And then your PhD, you also stayed in the same place?
Yeah, absolutely. So it was a 2-year master. And after that, actually, I first did an internship at Meteo Swiss, which is the Swiss Met Office, if you like. And they had this crazy project with the WMO, which is the World Meteorological Organization, to intercompare different instruments to measure snow. So just snow falling out of the sky. So not snow on the ground, but falling snow. And it was an international project with lots of project partners all over the world. And we basically just put these instruments in Davos on the Wijsvloerjoch, and we would then compare the output from these instruments. And that was a lot of fun. That was a year. And then after that year, the opportunity came up to do a PhD, which was also with Meteo Swiss and with the École Polytechnique Fédérale de Lausanne. So that's the EPFL in Lausanne. And I just seized that possibility. So,
wow. And what does that acronym mean in English?
It's the engineering school, if you like, engineering university, Polytechnical University in Lausanne, and it was a PhD in radar meteorology. It's all about doing both instrument science and science, which I really like. I love working with data that I collected myself.
And then what happened after your PhD? What did you then do?
I then started applying for different jobs, and this postdoc is pretty much the first one I found. So I applied to this Southern Ocean Clouds project with BAS, studying clouds, in Antarctica, basically.
And how many years have you been working with the British Antarctic Survey?
I think this is going on for my 5th year now.
Wow. So you are properly established.
And cloud physicist, I think, is my job description. Although I feel like that is something that you earn as you progress.
Oh, come on. You've been working on Antarctic clouds for 5 years now. And why Antarctica? You said this was one of the first postdocs you found. Was it because of the options and how the subject related to your interests, or was it the location, or both?
Both, yeah. So on the one hand, I've been just obsessed with measuring, snowfall, ice crystals. I just think, that's a wonderful thing. But also during my PhD, I sort of had this twice the opportunity to travel to the Arctic. And it was just one of those things which is pure chance. It wasn't planned or anything. Came across my desk and I seized the opportunity when it arose and went to the Arctic. And that was such a great experience. I loved it so much. I became a little bit obsessed with the polar regions from then on, and really wanted to work in the polar regions afterwards.
And where in the Arctic did you work?
So I went to Longyearbyen, and then I did this 1 month cruise to Franz Josef Land, which is an archipelago in the sort of Russian Arctic, if you like.
When did you first come to Rothera?
So my first time in Rothera was in the season of 2021, 2022. I only arrived in February 2022, and I remember it being incredible.
How did it compare to your experience in the Arctic? Did you notice much of a difference between the two poles?
Yeah, I think so. There's even more ice down here. It's from where I stand. Of course, I haven't been everywhere in the Arctic, but in the Arctic, it would be riverbeds. There'd be reindeer everywhere, and I think the Arctic, in many places is still inhabited, whereas you really feel like you've come to a very wild place when you come to Antarctica. This is, except for our base, there's absolutely nothing for, miles around. And you can tell that you've come to an incredibly remote place when you've arrived here.
Yeah, it's interesting that someone recently said to me, oh, so what are the native Antarctic people like? And I was like, oh, no, there aren't any.
Yeah, just that, except from recent history, no trace of human, presence really, which is incredible.
Back to clouds. Why are clouds so important?
So clouds have several important roles in climate. So on the one hand, they regulate how much sunlight reaches the Earth. So for example, when you look at satellite images, clouds are incredibly bright from, when you see them from outer space. And that's because they have what we call a very high albedo. When something has a high albedo, it just reflects a lot of sunlight back into space. And that can make that clouds have a bit of a cooling effect because all of that energy from the sun is just radiated back into space and it doesn't reach the Earth. But on the other hand, clouds can also act as a greenhouse gas, if you like. So they have a greenhouse effect. And through that effect, they can also have a warming effect. And it really depends on what the composition of that cloud is, sort of the timing of where they appear or what their altitude in the atmosphere is. So that makes it that it's not an easy thing to study because there's so many different things that can determine whether a cloud is warming the Earth or whether it is cooling the Earth.
How is a cloud actually formed? Because I remember you doing a demonstration of making a cloud in a bottle. So are you able to talk us through that?
Yeah, of course. So the ingredients for cloud are water vapor, obviously, and ideally you want something that causes the temperature to change. So that can be pressure. It can also be the air mass being forced to rise, like when it goes over a mountain range or something like that. And that will cause for the water vapor that is in the atmosphere to cool to such an extent that the water vapor will start condensing, and then it condenses onto a particle. So that's the other ingredient. We need these particles for the water to condense on, and then you can have water droplets forming.
And what is it about clouds in the Southern Ocean? Why do you want to study them in Antarctica?
So the Southern Ocean is one of the cloudiest places on Earth, and clouds just hang around here for a very long time. I think, anyone who's spent any time on Rothera knows that it can be quite cloudy, actually. But also it's one of the areas that is relatively understudied. And because it is relatively understudied, it tends to be not very well represented in climate models. So unfortunately, climate models have a lot of errors in these regions. And we observe those errors actually in surface temperatures, but those surface temperature errors are due to how the clouds are represented in these models.
How are you actually measuring these clouds in Antarctica? Like, what processes are you trying to capture?
So, we have different ways of measuring them. The facility we have here at Rothera on East Beach, we've got a number of instruments in there. We've also got instruments that look at the cloud height and their composition. But we've also been collecting these filters. So we pull the air, the Antarctic air, through these filters, and then these particles will collect on these filters. And then once a year, we send all of these filters back to Cambridge, where we analyze them in our lab for ice nucleating particles.
How on earth does that get set up right by the station, and where did you design all of these instruments?
One of the heaviest instruments that we brought over was brought round by people on a boat and then sort of brought on shore. But I wasn't there when they did it, but I've heard that it was quite a large logistical effort by everyone on base to get everything in the hut. Impressive.
It was, but that is the beauty of having so many people on station collectively coming together to help install these instruments. And Absolutely. They don't necessarily appreciate all the work that has gone into the minute measurements within these instruments or necessarily the process behind it, but they're so keen to help the science and to help build this structure that they know is really important. So I think that was really beautiful for it to come together, and that also you can always see a process of science happening just as you go for your daily stroll after work. You encounter the hut and you can see the laser actually radiating from the roof of the hut, literally.
Yeah, it's amazing. It's always so nice to be here because you really feel that there's so much support on base for science.
And you're also supported by the Aircraf unit, because another way of measuring clouds is through aircraft. So what's that about?
Yes, exactly. So that's what we're here for this year specifically, is for that flying campaign. So BAS operates a number of Twin Otters out of Rothera, and one of the Twin Otters, Alpha Zulu, AZ, or as I like to call her, and everybody does actually, Ice Cold Katy. She's the only Twin Otter that we can equip with our science kit. And she has these special hard points that we can attach instruments to and fly through clouds with. Obviously, we've got the standard temperature, humidity, infrared and short-wave radiation. But we've also got these really cool cloud probes, which do particle imaging. So as you fly through the cloud, you can see these crystal images or water droplet images appear on your screen. So you can see you can see live on your instruments as you're flying through the cloud what crystals are in the cloud that you're flying through, which is really cool. So the advantage of being able to fly through the atmosphere and also take vertical transects of the atmosphere by flying from very low levels to very high levels is that it gives us an idea of what the aerosol population is from the ground level up to higher altitudes in the atmosphere.
A little bit like the weather balloon, which we talked about in other episodes, taking that vertical profile throughout the whole atmosphere, sampling a range of different properties, but you're doing that specifically within the clouds. So exactly. What is it like being in this tiny red aircraft going through clouds, seeing them on the screen? Are you scared? Is it noisy? Do you have vertigo?
All kinds of things, actually. Yeah, it can be quite noisy on the aircraft. That's for sure. We have noise cancelling headphones, so that's all right. It's just so exciting to be able to be, so close to something that you're measuring and studying. How often do you get to see things live as they are happening and unfolding while you're also flying through it? That's just very exciting. And yeah, of course, there's some things that are quite particular of these Twin Otters. They're not equipped with a toilet, for example. They don't have cabin pressures. We occasionally fly with oxygen on board, so we have these oxygen masks that we put on when we go to higher altitudes. And then for the lower altitude flying, we have immersion suits. These are special suits that will keep you dry if you would have to land on water and make your way out of the aircraft. But these immersion suits, funnily enough, because they're water and air tight, as you go up and fly higher up in the atmosphere, they sort of start bulking out, because that's obviously what happens with the lack of pressure. And you're sort of like this little Michelin man inside your suit. And the very first time that happened, I was like, oh, this is uncomfortable. So I let out a lot of air out of my suit because it was just so bulky. And then we went back down again, and the opposite happens. And you're just squeezed into this suit as you go lower.
So you're like an inflated balloon trying to
Yes.
read the profile of the clouds, but actually you can't move your hand because your arm is swollen with air. Wow. And you obviously can't talk to your colleagues whilst you're wearing oxygen masks, right?
You can. So we have oxygen masks with built-in microphones, so that's all right. Yeah.
It's like a space operation. Wow. So did you ever expect to be doing that when you were doing your PhD and your postdoc? Did you think you'd be working
Never.
with an
No.
aircraft team?
No, never. No, because also you don't really hear. Well, I never knew this was a possibility, and I don't even, especially during my undergraduate, I didn't know that you could go and study clouds in Antarctica or anything in Antarctica for that matter.
So do you get good views sitting in the front seat, or actually most of the time are you just in a cloud and you don't really see where you're flying over?
Yeah, it's incredibly variable. So we always fly with two, well, pilots and then two crew members. So one of the scientists will be sitting next to the pilot in the co-pilot seat, and yeah, they will have quite a good view depending on where we're flying. Definitely, there's been days where we have almost exclusively clouds. But there's also days where you, especially for the low level legs, you have these incredible views, or as you go over Adelaide Island, you have these wonderful views of the mountains. And that's incredible. And you feel really privileged to be able to do that. But then if you're sitting with the instruments, so you're sitting in the back of the aircraft, and then you still have windows, obviously, but you're more focused on the instruments and you have much less view of your surroundings. It can even be very disorienting. So it's really hard to tell what area you're flying in where you're sitting with the instruments. You're just so focused on the data that's coming out.
And part of your team are also working on board a ship. So that's the Sir David Attenborough. And that's the first year, I believe, that instruments have been installed on the Sir David Attenborough as part of the Southern Ocean Cloud Project.
Definitely, yes. This has been our, first and unfortunately only cruise for the Southern Ocean Clouds project. But yeah, we installed a number of our instruments on the ship and made measurements as it sailed down to Rothera and then back out of Rothera. The idea is to have this really good idea of the spatial variability of all of these values. So there's some particles that might be coming from the ocean that we think have a role in how clouds form. And so being able to measure on the ocean, but in different locations, gives us a much better idea of what these processes might be and whether sea ice is important or whether it's still coming from the continent somewhere or whether it's predominantly phytoplankton or just salt, in bubble bursting and from wave formation that sort of lofted into the atmosphere. And one of the cool things that we did this year is because they came all the way down to Rothera, we were able to fly over the Sir David Attenborough as it came into Rothera. So we have the measurements at sea level, but we also have measurements in the clouds above the instruments on the ship.
That is just so cool.
Yeah.
Do you love your job?
Thank you. Yeah, no, I absolutely love my job. Yeah, no, that's absolutely true.
Do you ever get any downtime at Rothera?
Yes, of course, I do get downtime.
What do you like to do in your free time?
I'm just one of those people with too many hobbies and too little time. So I love to go skiing. So I'm a big ski fan. So I'll try and walk up with my skins. I've been skiing a little bit on the slope that we have behind the base.
The glacier. I love that you. This is how habituated you are to Antarctica, Floor, because you're like, oh, the slope, but it's actually you're still skiing on a glacier.
That's true.
I love it.
Yeah.
I love it.
What else? So music, there's a great music room and I love making music. This year, they've been organizing sea shanty singing, which has been such a cool thing to do. We've got like 2 or 3 different groups singing, in different voices, if that's the right word for it, and then harmonizing, which has been such a cool effort that you can, with so many people, form this thing that sort of just flows together. It's beautiful. It's really nice.
When we were there together, we had Spanish classes going on and we formed a little band. You were on the drums.
Yeah, it's different every year and it really depends on who is down here. And I think it gives you a measure of how creative people are and, what they bring to station every time they're here. And Knit Club is happening again this year. So that's always a favorite.
And during this season, as it's coming to a close, how many times have you been out in the aircraft?
How many times? We've had 20 flights this season, and a total of 74 hours of flying. Yeah.
Wow. What would you say the greatest challenges that you have to overcome are?
Yeah, the weather is a big thing. So to give an idea of how this goes, like you're undoubtedly familiar with the Met brief at 7:45 in the morning. So we all go into Met brief, and then the forecaster on station gives us an idea of what weather to expect for the day and for the next few days. And then depending on that, the pilot will decide on whether or not it's flyable weather or not. And then we can say, oh, well, we'd like to go and measure here, or we'd like to go and measure somewhere else. I mean, you come in with a bit of a plan in mind because you've looked at some of the forecasts before as well. So we've definitely had conditions in which we just couldn't fly. If the visibility is not good enough or there's strong crosswinds, then we can't fly out. Then we've also had conditions in which there were just no clouds. So what do you do as a cloud scientist when there's just no clouds around, I guess?
Go skiing.
Go skiing. And then there's just there's fatigue. So we have a team of four. There's always two people flying, but there's a limited number of flying hours that you're allowed to do, and then you have to take some time off because that's just a safety measure, which is thankfully in place, which is great. But you have to make sure that you keep an eye on that within your team, that the right people are taking the right amount of time off when that is needed. So that's always something to sort of work with. And then finally, there's technical problems sometimes. We've had instruments breaking that needed to be fixed. So then you have to ground the aircraft and fix the instruments. And luckily, with the aircraft, as usual, there was just, everything was fine, but you could have problems with the aircraft as well. And then you have to wait until that is fixed until you can go flying again. So these are all things that sort of come up in throughout the campaign and you have to deal with.
What are you doing next year? Are you coming back to Antarctica?
Oh, I'd love to. I don't know yet. So this was officially the last field season for the Southern Ocean Clouds project. But we've got funding to keep East Beach Hut going. So that will be continuing for the foreseeable future, which is great news. So this already quite long data series will be kept going. And I think that is a huge asset. But for me, in the next few months, it's going to be analyzing the data and writing up the results, which I'm really looking forward to.
So outside your life as a scientist and in the polar sphere, Floor, you also are part of the UK Polar Network. So this is an organisation that creates development workshops, education and outreach opportunities for early polar career scientists and for schools. And you've been within this network for at least the last 5 years. And from 2020 to 2021, you were the president. So amazing that you're able to fit this in amongst all your other obligations. And what's your role and why do you do this in addition?
Oh, it's just such a cool group of young people to work with, and I think the turnaround of projects is just so much shorter, whereas science can take a very long time. Like it can take years from when you first start planning things to when you actually start collecting data to when you start writing up your results and publishing them, whereas in the UK Polar Network it's just you're talking about shorter timescales, and it's just so nice to see the results of things on a much shorter timescale. But it's also just working together towards a common goal, which is, promoting science, promoting polar sciences, and just the enthusiasm that you get from working collectively with a group of people who are so passionate about the polar regions just gives me a lot of good energy, I think.
Going on to the personal element, I'd love to know what your nieces feel about their aunt being an Antarctic scientist. How do you explain to them what you do?
I think so my nieces are 2 and 5 years old, and I think the best way to capture their attention and imagination is to say that I'm sort of chilling out with the penguins, and that'll give them a better idea. The eldest ran up to me at some point and she was a little bit worried, and she went, Floor, but if you're down there on the, in the Antarctic, are you always upside down? Because somebody, and I believe it was her father, had told her that because it was the South Pole, we were always hanging upside down. And and for a minute, I thought I could just, run with it. And then I thought, no, she's being inquisitive. Like, I should reward the fact that she's actually verifying this bit of information by asking me directly. And so I told her that I wasn't, in fact, hanging upside down. But she was a bit worried about me having to do my work while being upside down.
To conclude, your work is all being contextualized in understanding climatic processes. And of course, hopefully everybody is aware of the state of the world. What are your feelings towards it?
Yeah, that's always a really difficult one, isn't it? Yeah. I think while you're here, you sort of sometimes are confronted with it when, it's much warmer, it's unseasonably warm, or, when you notice that animal behavior tends to deviate from what you would usually expect. So you're, in a way, constantly confronted with it. I think you also disengage a little bit by focusing just, specifically on your science and just keeping that in a different, different box, if you like. I think when it comes to the Earth, I've always felt like, well, it will find a new balance. It'll take millions of years, but the Earth sorts itself out and it will find a new sort of equilibrium. But whether human beings and how we fit into that new equilibrium, that is going to be the question. It's so very well catered to us, and large timescales is not something that we have encountered a lot in the past, and that we might not have in the future anymore. A climate that it actually allows us to live as human beings on this planet, so we should probably treasure it.
I think that's such a beautiful way to end, and thank you so much, Floor, for all the insights that you've given us today in this podcast.
Thanks for having me. It's just really nice to chat with you.
Floor's work is so fascinating, and she must genuinely have one of the few jobs where getting your head in the clouds is actively encouraged. But right now, she's in her element, analysing all the data she collected during her recent trip to Rothera. If you enjoy the ICEWORLD podcast, please do tell people and think about writing a nice review. Don't forget that all the episodes are available from the British Antarctic Survey's website at bas.ac.uk and wherever you get your podcasts. There are so many amazing stories from the individuals and teams who worked and are still working in Antarctica. Finally, if their stories have inspired you or you think a job in Antarctica might be for you, take a look at the jobs section, which is also on the BAS website. The next fortnightly episode will be about one of the first science cruises that took part on the Sir David Attenborough research vessel. It's called Biopole and is comprised of physical oceanographers and biologists, so stay tuned if you would like to hear what it's like to live at sea amongst icebergs and orcas whilst conducting precious and super interesting science. See you next time.